Welcome back to another HVAC-Engineering-Techie video. This video is different in that it's not a strict training video for HVAC, but it's a training video on knowledge about carbon and carbon pollution. Now, the reason I went through this journey, and I'm letting you share this journey, is I, over the last 3 years, have been serving on an ASHRAE technical committee on developing a guideline for building performance measurement protocols. How do you actually measure performance? That sounds like it's simple, but turns out it's complicated like everything else. So during that process, I was asked to look into the embedded energy in water and embedded water and energy, because both energy requires water and water uses energy. So I looked at those two things, and then they said, maybe you ought to look into carbon also. So I started looking into embedded carbon and fell into that ditch really quickly and realized that we don't know enough of what actually embedded carbon is. You realize that we don't know how much carbon it takes to actually build something, and the data that's out there is really not true. So there's a problem doing that. So that started me on looking at this whole carbon debate. And I'm a pretty stubborn individual, and I just don't pay much attention to news media, the babbling of news media. They'll say it's been reported, or they said, or leading scientists have said, but there's no depth there. So I want to take you through the journey of trying to figure this out. Now, I can't tell you that I figured everything out, because I'm definitely not a climate scientist. But I'm not a dumb guy either. I can figure things out if enough data is given to me. So this is the process I went through of trying to figure everything out. Now this unfortunately, today's video is fairly long. I apologize about that, but there's a lot of stuff to cover. So I've broken the video into 3 parts. Part 1 covers the basic facts about carbon and the carbon effect on Earth. So it's somewhat complicated, but it's doable to find that out. Part 2 is all about power plants. I always discovered that, I heard people say, well, let's just build solar power plants and we can solve this whole problem by it being renewables. Then I heard other people said, well, that's not possible because it would have to be too large. And I said, well, I can probably figure that out. I built solar fields. Early on in the earliest days of solar, I was out there building tracking collectors, so I know a lot about solar. So I started down that. So the second one is how much carbon does a power plant produce by each kind of power plant, and how can you compare the two? Because carbon is, the power plants are really complex in their efficiency, how they're operated, how they run, and what pollution they provide and what efficiency they provide. So part 2 is all about power plants and how to compare them together. Part 3 is with the data that we've learned through the journey of part 1 and through part 2, how do we decide on where to go from here? So I hope you enjoy these 3 modules. I enjoyed putting them together. It's taken me 1.5 years. This has not been a short journey. It's been a long journey, and you'll understand why when you look at them. So I appreciate you watching these. Please be a subscribing member by clicking the button down below. Give me a thumbs up if you like the video. Please share the video with other people. This is the first video I've produced that is open. You can download this. You can do anything you want with it. So it's not like my nano training videos. But anyway, I hope you enjoy it. Please become a subscriber. I would appreciate it. Thanks. Let's get started on the journey through this video. Thank you. So we're going to start off this journey of looking at carbon by first a little background so you can understand where I'm coming from, and what I am might actually help. It's a little boring, but it might help you. So I originally started working in the mechanical engineering field in 1965. I know, I'm an old guy, but that's when I started as a draftsman for a small engineering firm while I was going to college. In a few years, I went to work for a power utility and manager that manages an irrigation district which has 7 dams, 4 which are hydroelectric generators. I started up in the power utility side and ended up working in the water engineering department. So I had a kind of a wide breadth of things I did for the utility. And after 8 years working for several large engineering firms as a mechanical designer, I went to work for a mechanical contractor doing engineering and project management. This is where I started measuring CO2. I did this to judge the quality of the indoor environment. As I was setting up the projects that we built, I would measure the CO2 to make sure we had enough fresh air in the building, and that's when I first started doing it. We were around 350, 360 parts per million back then. We're now much higher, but that's how I started that. I became a lead AP early in the LEED program and performed hundreds of commissioning projects for all aspects of buildings, including industrial projects. Through the years, I have watched my CO2 readings increase from 320 to 420, and it is obvious to me that these changes were mostly caused by people. CO2 is not as homogeneous as you might think. I'd always thought that CO2 is 400 parts per million around the whole globe. Well, it is fairly homogeneous, except it has high pockets. It depends on what's generating the source. And that's how you can tell whether it's man-made or nature-made. Measurements near highways or swamps are much higher. I've measured CO2 in the middle of a swamp at 600 parts per million. And I had a building going in a swamp, and I had discovered it that way. And of course, doing outside air readings, if you're near a highway, they'll jump because of the motor traffic. So there is various level of CO2 within the globe. I've been watching and listening to the CO2 predictions from 2006 when it was publicized by Al Gore promoting the IPCC through the film An Inconvenient Truth. Now, the IPCC is kind of a faceless committee of the United Nations. Eventually, Gore identified scientists James Hansen and Roger Revelle as major contributors to the doomsday scenario of CO2. Because there's a lot of CO2 scientists that had publications of what they did, but they would never make a prediction that CO2 is going to end the Earth. That is not an engineering science deal. So this actually came through the IPCC. Now, I didn't know this when I started out, so I kept trying to find the science behind everything. It was not until the near end I realized what this was all about, and we'll talk about it when we get there. I did not become alarmed about it until I heard some fellow ASHRAE engineers say we must stop burning all forms of fossil fuels immediately to stop the increase of CO2. Now that set me back because these are smart people. They're all engineers, and these dumb statements were made without regard to what is possible. They were just listening to the news and saying, oh, this is a dire situation. We have to act, and the only way we can do this is by stop burning fossil fuels. Now, I knew right away that can't happen because, it's okay if you live in Southern California. You can use a heat pump to do your house. But you can't do an industrial process. If you're smelting copper, you can't use a heat pump. You have to burn fuel. You can burn electricity, but how do you make the electricity? That's the other question. They said, well, we'll just do solar. No, you won't. And there's a problem with that, and I'll explain it later. So this started me on the process. I said, these people are not thinking. We've got to figure this out because these are stupid statements, and we'll go through why. So what did I already know about CO2? CO2 level from 1965 to 2020 has risen from 320 to 420 parts per million. Now, it even surprised me that it's that high, but that's not a problem. I mean, 420 is absolutely no problem in CO2. And in HVAC, we use CO2 as a tracer gas, limiting building CO2 less than 1,200 parts per million. And the 1,200 parts per million is really not hard science. It's just kind of an observation. And the observation we always use is you get high up, you get to 3,000 parts per million, people start getting sleepy. And I observed this when I was teaching classes. We set a CO2 meter up in front of the room, and as it started out at 370 parts per million, and slowly it built up until it got to about 3,200 parts per million before we break for lunch. And people be yawning and, kind of getting sleepy setting. But it turns out the science is the CO2 is not the cause of that. It's something else. We don't really know. But 3,200 parts per million doesn't hurt you. So it's not a problem. Remember, CO2 is not a pollutant. That's been made up by the news media. It is definitely not a pollutant. You can't survive without CO2. CO2 is a gas that's required for sustaining life on Earth. So it's not a pollutant. It's a gas we have to have. Higher levels of CO2 will not deplete O2. You know, we used to have people in my class would say, well, let's just measure the oxygen because then we'll know when CO2 is starting to delete it and it won't work. It turns out that CO2 is very, very easy to measure, and that's why we use it as a tracer gas. Oxygen is harder to use it, but I'll show you why that doesn't work. Here it is. So here's the atmosphere. The atmosphere is 78% nitrogen, 20% oxygen, and 0.91% argon. And then we have all these other gases, carbon dioxide, methane, nitrous oxide, a whole bunch of them I can't pronounce, and water vapor. Now, water vapor is about 0.15%, not 15%, but 0.15% of the atmosphere, and is by far the most greenhouse heating gas. It does more to heat the earth than any other thing we have. And then carbon is way up here, and it's only a piece, and all of these added together is 0.04%. So how much of this do you have to move the needle up here on oxygen? It ain't never going to happen. You know what I mean? Is because this will not move the needle up here at all. So you can't measure oxygen to try to tell how much CO2 you had. Now, believe it or not, in our industry, someone tried that. A manufacturer said, well, we'll put an oxygen sensor out there, and you can tell. No, it didn't work because it always hung around 20%. Nothing seemed to matter. And the reason is because it's one of the noble gases up here, and it has a whole bunch of it, and these down here are really, really small. CO2 is not a pollutant, but a beneficial gas. Level as high as 3,500 parts per million are not harmful to life. Now, do I want to run at 3,500? No, of course not. But run 1,000 parts per million all day long without a problem. I mean, you don't want to panic and say this is a pollution gas that's going to be harmful to people, because it is not. And not only that, it's very beneficial to plants. Plants eat the stuff. You know, they take it and take CO2 in and put out oxygen. That's actually a lot more complicated than that. But the present increase in CO2 is caused by both natural causes and man. I've heard arguments out there in the news media that it's not caused by man at all, or that it's all man-made, and both of those are absolute lies. I mean, it's so fake, it's not even funny. I mean, it's just fake. So what's the sources of man-made CO2? People and domesticated animals outgassing and breathing. Those provide CO2, and they provide a lot of it. So, you know, some people have actually said, they said it very quietly, but the way to solve carbon is get rid of half the people on Earth. Now, I don't think killing 4 billion people is a good answer, but people have said that, which is ridiculous. Burning of fuels, any fuel, it doesn't matter if it's wood, cardboard, paper, gas, oil, coal, it all provides CO2. And anything a man does that way does do that. Manufacturing, mining, and industrial processes, all of these provide CO2 to the atmosphere. You just can't get away from it. It happens that way. And what are the sources of natural CO2? Outgassing the ocean. The ocean outgasses. The ocean is a large CO2 sink, and it absorbs, the plankton in the ocean absorbs a lot of CO2, but it also has a capability of outgassing CO2 to the atmosphere. Wild animals outgassing and breathing, they also produce CO2 to the space. Now, this is more complicated. When the plant respiration of CO2 and O2 out in the daytime, CO2 out at night. So I didn't realize this. I thought that, originally from my third grade class, is plants eat CO2 and they exhale oxygen, and that's how we get our oxygen to breathe. But actually, they also have another process in there creating this oxygen that requires some work inside the plant, and it actually burns oxygen and the sugars in the plant, and they exhale some CO2. So during the nighttime, there's no photosynthesis going on during the nighttime, so they CO2 comes out at night with that process going on inside the plant. So anyway, that's plant respiration. Decomposition of organic matter has stuff decomposes. CO2 is a natural byproduct. Volcanic eruptions issue a lot of CO2. And forest fires. The trees are carbon sinks, so they will take in the carbon, and they built inside the trees, all made out of carbon. Yeah, you realize that all life on Earth is all carbon-based. So anything that burns or disappears or dies all releases some of the carbon that they've gained during their lifetimes. So forest fires certainly can be that. And then natural weathering of carbonate rocks, limestone and dolestone. As these weather, they release carbon that they have absorbed during their lifetime. Now, you realize that early on, and I'll get into this later, but there have been times in Earth's history where the CO2 is many, many times higher than it is now. I mean, clear up to 10,000 parts per million. During those times, these rocks absorb this carbon because they're somewhat of have an affinity for carbon. They will absorb it. So that's how limestone was created, is because all of this carbon was in the atmosphere and it drew it out of the atmosphere. Photosynthesis, plants and trees convert CO2 to food. That's what they eat. Ocean absorbs carbon, sink mainly from photoplankton absorption. So that's how they get how they drink in carbon. Reforestation or forest growth, greening the planet is a good thing. So as I did a job early on for one of our universities here where they put in a laboratory, a plant laboratory where they planted trees. Actually, they were funded by the citrus industry here in Arizona. So they basically put up a bunch of trees and built airtight containers around them, clear air conditioners. They could still see sun, but the atmosphere they could control, and they pumped it up to different levels to see what it did to the trees. And I've seen a recent study done also with a pine tree, and of course plants love about 1,000 parts per million. That's what they really like. That's their sweet spot. And when that's found, they really get good. And so I've found an article that talks about the greening of the planet, how even going from 320 to 420, the deserts on Earth have beginning to green. And one of the reasons is because that's more food for them. Soil carbon sequestered by organic matter in the soil. So that's also possible, that you can sequester carbon dioxide in the soil. Certain types of wetlands can effectively absorb and store carbon. Certain types of rocks and minerals naturally react with CO2, essentially locking away. And that's this limestone and dolestone. What made me suspicious of all these doomsday claims? It was worrisome when prominent scientists were being labeled as climate deniers and not allowed to publish any research that questioned the doomsday climate narratives. Science, without doubt, is actually a religion. This is what this was turning into. It was turning into climate fascism. You know, don't talk to me about the science. Just believe this narrative. You're going to die because of CO2. And I couldn't figure out why would anyone even want to do that? That seems so silly to me. Why would you try to blackball another scientist who maybe has been in the industry for 40 years and has a lot of accolades about the quality of his science, and all of a sudden now he's a climate denier and you can't believe anything he says? That rings bells in my head. I don't know. I could never see the actual science that these people were basing all of this on. So that was also troublesome. Now, I know it's complicated. I know climate science is probably one of the most complicated subjects around. I also know that there is actually not a title climate scientist. There's about 12 different disciplines around climate. People who do different things. There's not one person that's smart enough to know everything about the climate, at least that I know about. And there's certainly not a college education process saying this produces a climate scientist. You might be a weatherman, you might be a weather scientist, you might be a scientist that studies the outgassing of the earth. There's all kinds of things, but it's not one simple subject. The act of politicizing the science as climate was obviously cause for nefarious problems. Now, this is where I found at the end of my journey. I kept trying to find I'm a technical guy, right? I wanted to see the technology. And the conclusion I finally came to, and it was upsetting for me to find this conclusion, is the politicization of the science of climate was obviously caused for nefarious purposes. There's no other reason I can think of. I think this was done to be able to push a narrative that benefits the few who adheres to this narrative. The goal of this politicization can only be to gain total world control through climate science. I mean, and they did that. They were very, very successful in being able to persuade the whole world that we're all going to die. That's what, of course, we all will die someday, but I don't think we're going to die from CO2. What I eventually discovered is that the IPCC report, first draft, is composed of the scientific reports that they have accepted been accepted by the IPCC committee. This is basically the first draft. Then the IPCC Managing Committee selects which studies are brought forward into the executive report, which is then debated by the political bodies within the United Nations. So basically, they have a bunch of fairly good scientific studies, and then they call that. Now, remember, that first draft is by who they selected, and they only select reports that align with the narrative of climate catastrophe. And then the committee, not the actual scientists, but the managing committee of the IPCC selects which ones they want to bring forward into the executive report. And then the executive report is given to the political body of the United Nations, and these nations debate what to change in this report before it goes public so that their individual political bias is not damaged. This is how the notion of a political catastrophe because of climate is kept going forward, because the IPCC generates it and wants it going forward for whatever reason. I don't know what those reasons are. They can't be good reasons, because they're not looking at all the science. They're only looking at a piece of the science. So there's something that's not right here, and this is a smoking gun. The IPCC is the cause of the problem. The IPCC is the one that generated the problem. The IPCC is the one that continues to do the problem. Now, you got to admit, these people were able to fool the whole world. I mean, nations like Germany and other nations have bid off on this hook, line, and sinker. And the U.S. has also until now. Until now, they're beginning to get away from this, saying this is not true. So hopefully this is helpful, but it took me a long time to get here. I was always looking for the scientific reason, but there's really none. It's a political reason. So let's look at some of these predictions. Obviously I realize these are cherry picked, so there's probably a lot of others that weren't cherry picked. Now, as I get into this, I guess I need to let you know that I'm kind of a middle of the road guy. I tend to not to be way left or way right. I'm kind of in the middle of the road. And I had a friend who was a minister, and I listened to one of his sermons. He was a country minister, and it was about dirt roads. In the country we have dirt roads, and dirt roads are built on purpose a specific way. They're slightly crowned, and they have what we call a bar ditch on both sides. And the bar ditch is there to catch the water and get it off the road, because dirt roads and water do not mix. You do not want a muddy road, because they are really difficult to run on. So they put bar ditches to get rid of the water so the road wouldn't get that wet. And his sermon basically was, stay out of the bar ditches. No good can come from you being in a bar ditch. Now, a bar ditch is like 18 inches deep, and so it was hard to get in and out of those, and you could get stuck, or it could basically derail you. So you wanted to stay out of the bar ditches. And his realization was it's the same in life. You want to be in the middle of the road. You don't want to be in the left bar ditch or the right bar ditch. Those are extremes. You want to stay in the middle so you can hear everything, listen to everything, and be objective. Here was a prediction. Climate science predicts models all agree on a future climate catastrophe. Now, there's this thing. Scientists believe, and they all believe, if we do not stop burning fossil fuels and generating CO2, we're all going to die. That was their prediction. Now, this is one of the early ones. This is one of the early predictions of this particular model. And what they did is they ran this model for all kinds of different, this gets really complicated and it's really hard to understand, and I can't say that I fully understand it. But basically these models are predicting from basically science-backed measurements, predicting where the anomalies will be in science due to higher CO2. And these lines over here was the predicted net temperature. Now you got to understand, these are not actual temperatures. These are surface of the troposphere temperatures that affect down below, and this is supposed to be the general temperature, and this is in C, of course. So this is what these models look like. So these guys back here said they predicted with our models we could, now each one of these lines is a different model, so it could have been way up here at 1.5, 1.8 C change in the temperature, or it could be down here at some of the lower temperature, and these are the years. So these are their predictions, and this red line is the mean, the average of all of these, if you say so. And so they were all predicting that we're going to get to about 1C by 2024. And so that's where they were basing that on. Well, we have other scientists that their job is to actually measure all this stuff. And so those scientists were plotting the measurements, and these measurements, the blue are actually high-level weather balloons, where they measure the temperature, and the other one, the green ones, are actually satellite data, which is by far the most accurate. And the reason is because the satellite data covers the whole surface of the Earth, whereas a balloon is only going to do that little bit of space. So these are the actual observations where you go, what the heck? This is really different. So these guys are saying this is going to die. We're going to die because of these high temperatures. And they're going, well, it's not happening. Why? And that began the firestorm of the last few years, of where scientists say we don't believe these models because they're not working. Well, what they don't tell you is that these models are based on prediction, based upon some very accurate predictions. However, when you put them all together and you try to make a prediction, I mean, what I've said is, predicting the weather next week is really hard. Predicting the climate years from now, it's impossible, to tell you the truth. We can kind of get an idea what's happening, but this is impossible. And we'll go through the others too. So here's a prediction of 2004. A new study of global climate models used to project Earth's future global average surface temperature over the past half century answers that question. Most of the models have been quite accurate. What? Well, we just showed you the measurements, so here's what they were talking about. This one's in C and this one's in Fahrenheit, or the other way around. I mean, which one? Yeah, this one's in Fahrenheit, this one's in C. That basically they predicted these models, and the red one is the actual measurements, but these are not the measurements of the temperature of the Earth. These are measurements of the 95 percentile predicted mean. So it gets so complicated, it gets so convoluted down that you can't really use any of this data for actual predictions. So again, this is the outcome. This is the difference. So you said they're quite accurate, but accurate to what? What he was saying was these models are accurate to this measurement, and this measurement we made. But the measurement does not measure the real temperature. It's trying to measure some a 95 percentile facility, and it's not working. Now, I've listened to some scientists try to explain that to me. I'm a little dense. I didn't get it quite. So I'd have to study a lot harder to figure that out. But when I see the actual measurements, I don't have to study hard for that. I can figure it out. If you measure 14C, that's 14C. But there's a lot of things behind the scenes here that are kind of gimmicky. Here's another prediction. Climate alarmists have said CO2 levels are causing ecosystems to collapse, and higher levels will doom the planet. So, and so you say, okay, and what are they saying? They're saying that CO2, there's an argument about what they call a hockey stick, and I think I'll talk about it later, but the hockey stick was based upon this upturn in CO2. This was based on the upturn in CO2. And this purple line is CO2, and the blue line is actually temperature of the Earth for the last 570 million years. So it's a long time, right? Well, this is back in this age, is when all the oil was produced on Earth. And you can see the CO2, it got really, really high. Well, this hockey stick thing, which we'll talk about in a second, actually said, it's an IPCC report, that with an increase in CO2, you get an increase in Earth's temperature. And everyone said, okay, well, past history says no. Past history says correlation is very, very weak. And in ag, several times, temperature went first before, this temperature went first. And it's not exactly a direct correlation. So this hockey stick is somewhat of a problem. This is historic CO2. In reasonable times has been as high as 5,800 parts per million, or low as 180 parts per million. So it's really varied over Earth's lifetime. Now, how do they know all this stuff? Well, they know it by soil samples. They know it by ice core samples, how to get back to those areas. So this is that hockey stick area. It's right here. This is exaggerated. We'll see it in a minute. But this is the greenhouse gases, and this is the CO2 level. Now, they're using CO2e, which is equivalent of a CO2. So there's a lot of other gases that are much more potential Earth warming than CO2, like methane. So basically they say, okay, 1 cubic foot of methane is equal to this many cubic feet of CO2, and that's how they've done some of these calculations. And this here statement is somewhat misleading because it's saying, the statement is misleading. It says the CO2 record with data to 1990 includes a CO2 rise shown in this figure. Here is a dramatic jump to levels not seen on Earth for hundreds of thousands, probably millions of years. So that statement right there makes you think, well, boy, we're in uncharted territories. Well, that's misleading because what they've done is narrowed the range of what they're looking at to really scare you. Is what it's all about. So here's the deal. So they're saying that level of increase. Now, they are correct in that the level of increase over time has never been, well, you know, and like way back here or right here, we may have seen it, but that's, you know, that's 65, 80 million years ago, 100 million years ago. So here you see this 1,200 parts million was 14.3 million years ago. That level right there. And you can see it's been below that a few times, and most of the times of Earth's history, it's been above 1,200 parts per million. And that's why we have a green planet, why we have so many fossils and so much oil in Earth, because the plant life, the biomass, was very high because it has a lot of food to chew on. So that's done it now. Also, back here at about 160,000 years ago, we had 300 parts per million 160,000 years ago. And then right here at about the time man started getting here, we were down to 180 parts per million, which is scary. And we'll talk about that in a minute. Okay, another prediction, 2004. A secret report suppressed by the U.S. defense chiefs and obtained by the Observer, this is an English article, warns that major European cities will sink beneath rising sea as Britain is plunged into a Siberian climate of 2020. Nuclear conflict, mega droughts, famine, and widespread rioting will occur across the world. That's a kind of a bold prediction. It didn't happen, but outcome 2020. Britain continues to have normal seasons. It's not a Siberian winter. So what I'm trying to say is, you're trying to predict climate 20 years in advance. Absolutely, you're a fool, because it's impossible. Past predictions. Prediction: climate headlines promote fear over scientific facts. News states snow is a thing in the past. Well, I think there's some people right this moment in the East Coast kind of wish snow was a thing in the past. So this article, this guy said that children in the future won't even know what snow is. They'll see it in the history books, but it won't actually see it anymore. However, the warming is so far manifesting itself more in winters, which are less cold than hotter summers. So basically what's happening to the planet is it's becoming more temperate instead of extremes, very, very cold. It's actually now kind of warming up in the lesser extremes, so it's becoming more temperate. And here's how the outcome is. This is the level of North American snowfall anomalies. So you can see for this period we had less snow, but now for these periods we had more snow than normal. So you can see there's normal variation, which is just continuing as it always has been. Prediction in 1970. In a decade, urban dwellers will have to wear gas masks to survive air pollution, reported Life magazine in 1970. At the present rate of nitrogen buildup, it's only a matter of time before light will be filtered out of the atmosphere and none of our land will be usable. Ecologist Ken Watt. Now, why do news media publish such stories? You got to realize that's, he's 50 years out, and he made this kind of prediction. It's a fool. And the reason news media does, and you got to understand, they're trying to make a living, and they make a living by getting more people to read their paper or their magazine or whatever. So they need to emphasize or exaggerate anything they can to get a headline that grabs a person's attention. So they do that. They falsify it, they exaggerate it. A catastrophe is a good thing. So this climate crisis has been great for the news media because they can really scare you. They can sell a lot of papers. They can sell a lot of magazines based upon this fear factor, which is unfortunate. And of course, as nebulous as this prediction was, there's no buildup of nitrogen or nitrogen compounds in the atmosphere, and crop production is at an all-time high. So basically, this prediction was not just a little wrong; it was totally wrong, and that's unfortunate because we don't need that kind of predictions. We need to know what is true so we can plan out what to do. So prediction 2020, David Berner, a senior research scientist at the Climate Research Unit of the University of East Anglia, said within a few years, winter snowfall will become a very rare and exciting event. Children just aren't going to know what snow is. That's the guy that said it before. Continues to snow as much as in previous decades. California may be setting an all-time high snow record in 2023. Now, does that mean that climate change is not real? No, it does not. It just means the catastrophe part of it is not real. And that's what we need to kind of get into our belt. Prediction, global temperature to rise 3 to 4 degrees by 2020. You can see in that one graph we did mention. Now, this, unfortunate, is a pretty prominent scientist, and why he went off the rails, I do not know. So James Hansen, a climate modeler with NASA's Goddard Institute, predicted global temperatures will increase an additional 3 to 4 degrees sometimes between 2010 and 2020. It didn't happen at all. So here's an individual, a smart guy. He's a well-respected scientist. He's employed by NASA, was employed by NASA, but he got wound around his own axle. He believed his model so much that he predicted this catastrophe, which is a problem. You can't fall in love with your own math model too good. You have to be able to let some other people that have questions about it ask them, because he definitely made a mistake. And here's the there's 0.5 degree change in 2021. So instead of 3 or 4 degrees, it was 0.5. Was it change? Absolutely, temperature's going up. And so what we need to understand now, why the temperature's going up is some a matter of debate. I believe it's a matter of all things. The reason it's going up is because of Earth's change. That has nothing to do with us, and it has to do with us. So both are contributing to this change. All right, so let's look at a temperature record. So here's a temperature record. Here we'll talk about the hockey stick. So here's the difference, and this is from this is like 300,000 years ago, 200,000, 100,000 years ago. And this is where it comes down. You can see the red is the temperature and the blue is the CO2. And you see they're tracking fairly closely, which is not an issue. Now here you can see the temperature is rising without the CO2 changing, which means these are not really correlated that well. And then here's this hockey stick deal up here. So let's talk about that a little bit. This is man-made, and natural CO2 has caused this up to 400 where we're at here now. Okay, here's another thing that's confusing, even to me, even though I know what's going on. These gray lines are the temperature measurements for these predicted models. Now, what that is, it's the 95 percentile. So what they said is we want the model to be able to produce an accurate output within the 95 percentile, which says you're going to be the 95% of this is going to be accurate to this point. So it produces, this is an outlier, and this is an outlier. So anywhere in between here, if the temperature falls in here, the model is still good at 95%. Okay, so but it doesn't mean this is actual temperature. This is that the temperature that is part of the model basis, and this is what the mean of these temperature rises are. Now here you see that you can see here's that loop, and then you can see that it starts rising, and it goes up to this 400 deal level again. This is the 95% confidence level, like I said. Here we're back to that same chart again. And right here, right as we started up, we were at 180 parts per million. Now, why that's a problem is because plant life dies if it gets below 150. So we're basically blaming man for taking the CO2 above that 180 parts per million. So we came very close. And like one of the famous scientists says, man saved the earth from catastrophe, and by adding CO2. When man first came along, he started burning fires and started adding more CO2. Now, of course, nature helped. Nature had volcanoes and things that helped the CO2. But this is really important because a lot of people out there believe what the news media has told them, that CO2 is a poisonous gas. It is not. We die without it. And that's the scary thing that people are so wrong about that makes me wonder. And these are areas where no CO2 and temperature correlation. So there's times when the CO2 and the temperature don't correlate at all. So why would it do it now when it didn't do it in the past? So it was 18,000 years ago when we reached this low point. So we need to make sure that I believe we need to conserve on CO2. We need to produce as little as we possibly can within practical means. But too low, you're going to kill the earth. Predictions: global warming will cause droughts in the West and Midwest in the U.S. in the 1990s. More droughts likely, expert tells senators. So again, news media, they said, it's been reported, scientists say, which is a problem. So this is the place where Hansen said we were entering these droughts. This is where he did his model, which indeed was, this is precipitation. The green deal is rain. And he was indeed in a drought when he created the model, and he predicted dire straits based upon what he was. Again, he let his model get the best of him. There are many more. They fail to realize that climate is not weather. It's much a different animal. Predicting weather a month in advance is hard. Predicting climate years in advance is impossible. Prediction 1986. Dr. James Hansen, same guy, a leading climate modeler with NASA's Goddard Institute of Space Studies, predicted that global temperatures should be nearly 2 degrees higher in 20 years, and said that average U.S. temperatures have risen from 1 to 2 degrees since 1958. It is predicted to increase an additional 3 to 4 degrees, and that was that same prediction, which obviously did not happen. As of October 21, according to satellite research, global temperature is less than 0.5 degree warmer than in 1986. So his predictions were way off. Now, I agree, this is in C, which is going to be about 0.7 Fahrenheit, so it's not going to be that. One thing about converting centigrade to Fahrenheit, it's one thing to connect the two to actual temperature, like 15C being 70F, but when you're kind of convert just 1C to 1F, it's a little bit trickier. You got to figure that out because it's a difference. It's not just a thing. So this is a global temperature rise. It's 0.5 degrees. You can see this is from 1985 to 2000. You can see this is the temperature line, and this is how much that temperature is raised. And here's what it is. So you can see it's at about 0.5 C, half of that. So it's 0.2 C. It raised over that time. This is James Hansen again, said that space studies and during his Senate hearing that the overall temperature of Earth rose sharply this year, signaling the beginning of the greenhouse effect and signifying increasing the likelihood of droughts and heat waves in Southwest and Midwest. The newspaper headlines: more drought likely, expert tells senators. Last really dry year in the Midwest was 1988, and recent years had record precipitation. So basically, that's where he was at. He predicted based upon his model, which has been totally proven as wrong. So again, they're saying, oh, we're really accurate. Well, actually, you're not really accurate. So what's the takeaway from these failed predictions? Predicting the weather months in advance is difficult. Predicting climate events in years is impossible. Earth has many variables reacting to climate change that are unforeseen and can drastically change outcomes. And these are both positive and negative. And what happens is it appears to me that the studies I've said, they are including the changes that could increase the outcomes and ignoring the ones that would decrease it, which is somewhat problematic. You realize entropy happens. So most natural things in the atmosphere and in the world actually decrease outcomes, not increase, because you realize it takes more energy to increase. It doesn't take more to decrease. So that kind of is the problem. You know, I have it in there somewhere. I'm probably out of sequence. But they have been publishing scare points of tripping points. You're going to trip a trip point and the atmosphere will now run wild, out of control temperature and destroy the Earth. Well, that's absolutely not true, because tripping points, as one scientist, I've forgotten his name, but he said, you know, a system in the Earth cannot change drastically, have a tripping point, unless it's tightly constrained to 2 or 3 points. For instance, let's take water. H2O has 2 tripping points. It has a tripping point between ice and water and a tripping between water and steam. So it's tightly constrained. It can exist in 3 states. Most things can exist in 2 states, but they're not tightly constrained. So there's nothing, if it's not tightly constrained, they can all just automatically make it trip. And people are making the most foolish assumptions that we all of a sudden are going to lose 20 degrees surface temperature because we hit a tripping point, or we're going to hit a tripping point, we're going to gain 20 degrees. Those can't happen. Those are actually falses. So we need to understand that things do change. Negative feedback loops. One of the scientists I read, he said that we're going to get much hotter because we're going to hit a tripping point, and we're going to have a additive feedback loop that's going to increase the temperature. And what he was speaking about, as the atmosphere gets warmer, the Arctic is going to melt, and all the CO2 and methane gas stored there will escape and cause a huge tripping point. Well, it's already happening. It's already going to the atmosphere, but it's not a tripping point. And that's an assumption. And also, there are places in the Arctic that are actually getting colder, which I don't understand. But basically, this guy didn't understand either. Atmospheric moisture. Now, that's another thing that's really concerning. If you read the basis of any of these models, they exclude the effect of moisture, water vapor in the atmosphere, even though it's the greatest warming gas there is. But they said it has no practical effect. Well, it has all kinds of effect, and the only good news is it's very short-lived. Water vapor does not stay in the atmosphere very long, but ignoring it to your peril, because it can change your outcomes drastically. So I thought that was interesting. Do failed predictions mean the whole climate issue is fake and can be ignored? And my answer to that is absolutely not. You want to pay a whole bunch of attention to pollution because that can kill you. And 2, you want to not damage the atmosphere if you can help it. But letting the atmosphere go to 1,000 parts per million is probably not going to kill it. And it does not deserve the attention it's getting right now. Do failed predictions mean CO2 is not a problem and we can ignore its buildup? The answer is no. We can't ignore it, but we don't have to panic about it and basically doom our economies. Because if we doom our economy, we can't do anything about anything. Does it mean we should panic and stop all sources of CO2 immediately at any cost? No. Okay, the political divide. I discovered that the carbon catastrophe was politicized by the United Nations IPCC, assisted by Al Gore through his An Inconvenient Truth movie. The IPCC continues to push the catastrophe narrative by manipulating the science of the IPCC report, which only includes one side of the debate. They pick the narrative. They restrict their report to the narrative. This really shook me up. When I actually figured this all out, now maybe smarter people know this right up front, but I did not. I actually thought there's a bunch of scientists that contribute to this, and the best scientists are selected by scientists. That's not the case. There are a lot of scientists that contribute to the phase 1 of the IPCC report. And they're smart people. They're good people. They're not crazy people. But the IPCC only selects scientists that agree with their narrative. If you're a person that says that narrative is not true, the IPCC will not accept your report, which everyone should know is a big red flag. You got a problem. If you can't question scientists, as one guy I heard talking said, then it's religion. If you can't question the science, then you're in a religion. And that's what's happening here. So climate exchange extremists, our world is coming to an end because of runaway CO2 pollution. That's absolutely false. Man is adding more CO2 faster than any time in the past, the hockey stick. True. Not in quantity, but over the amount over a short period of time. Now, the thing about the hockey stick is somewhat concerning. The IPCC had a group of scientists that did studies, several different studies about this buildup in CO2, and they picked one guy to take his narrative, which he called the hockey stick, and they elevated his report to the next level of the report, and ignored the others. Which one of the others said, "Well, this is not true," and he had some rebuttal to that case, but they ignored him because they liked the one that said the hockey stick because it really was something they could get their heads around. The world will soon become unlivable due to excessive heat, due to runaway CO2 pollution, positive feedback loops. That's false. As far as we know, there are absolutely no global positive feedback loops. There's a lot of little ones, but there's no global positive feedback loop. There are some negative ones, like as you get higher the CO2 level, the more the natural removal happens. You know, if you get high enough, the rocks will start absorbing it. The higher you get, the oceans will absorb it. So there is a tipping point coming when CO2 will double or triple over a very short period of time. That's absolutely false. Unless the Earth, all the volcanoes on Earth erupt or something like that. It's not going to happen. I mean, this is actually a false narrative. And there's nothing you could do about this anyway if it was true. Climate change deniers. There's an emergency. There is no emergency. CO2 level is all naturally caused. That's actually not true. That's false because man does definitely recreate some CO2. Earth has seen CO2 levels greater than 5,000 ppm in the past, and that's absolutely true. It's been as high as 10,000 parts per million. Life on Earth was facing extinction before the current CO2 buildup began. 100 ppm, less than 150 ppm plants die, and that's absolutely true. People need to understand that. The world needs energy to improve the quality of life and to help people be healthier and to live longer lives. We cannot stop developing countries from seeking a better life, which means more CO2 in the air. Basically, we're living longer lives than any time in man's history because of energy. And energy, we've made energy with CO2, and we will continue to make energy with CO2. There's no getting around that. I mean, even a solar and a windmill has CO2 coupled with it. You can't get out of it. It takes CO2 to build them. It takes CO2 to operate them. It's always going to be there. So you do not have a source of energy that has zero CO2. There's CO2 embedded in everything because we're carbon-based life form. This is kind of a chart of where this is available online. This was World Resources Institute. It talks about the CO2 coming from all of these. This is from methane. This is all from CO2 sources. And you can see the different, like here's roads, here's residential buildings, here's commercial buildings, iron and steel production. So there's all kinds of things here that produce CO2. And it only just gold. So greenhouse gases, what are they? What's in our atmosphere? So here we go. Here's the nitrogen, oxygen, and argon. And here's the percentage of those. And the greenhouse gases are water vapor and CO2 and those other gases like I showed you in the past one. So what are the greenhouse gases? Water vapor is about 50% on a clear day and about 75% of the earth warming gases. This is what it does. You see, CO2 is about 19% and 19% of both days. And CH4 and NO2 and all these others produce more. It comes up to about those different averages. Greenhouse gases, what are they? So let's look at about what they are. These are the ones in the atmosphere, and now let's look at a little bit. These are how long these things last in the atmosphere. See, water vapor lasts about 10 days, and all these others have years, 12 years, 109 years, 100 years, 12 years, 5 and 14 years. These are the refrigerants. You can see 50,000 years, 10,000 years. So you can see this is why we've been banning these refrigerants to get them out of the atmosphere because they do affect the atmosphere. Now this is carbon dioxide. So in 1 year, CO2 is still there, 100% of it. In 10 years, only 80% remains. 100 years, 40% remains. 1,000 years, 20% remains. 10,000 years, 10% remains. So that's the problem with CO2. It's a long-lived gas. It's hard to get out of the atmosphere. Or water vapor, even though it's more potential, it doesn't take long to get out of it. But why the models would exclude water vapor is just a way of making them inaccurate. So here's COEs, CO2Es. These are the equivalents. And this talks about the equivalents. You can see here that these are lifetimes. So CO2 is 0.04. So these are the different equivalents. Here's their global warming potential of these different gases. Water vapor amplifies warming, but is not consistent across the world. That's true. Water vapor is not consistent, and that's why they've excluded it from their models. But when it's there, and it makes a big difference. This is another one that you could clip and use this if you want. It shows how the gases change the temperature, and these are not the most important ones to me. I mean, they show it may be somewhat confusing, but the incoming solar radiation is about 342 watts per meter squared, and that's where the sun comes on, and then all this other is the Earth absorbs it and bounces it back into the atmosphere. So what they're trying to measure, the scientists are trying to measure the net effect up here, the net effect of coming in and going out, what's left, and what is warming the planet, and that's what we're going to talk about. So here's the most important thing we're going to talk about. The next couple of slides is a lot of people assume that CO2 heat absorption is linear, and it is not. See, unfortunately, CO2 absorbs temperature in different quantities in different frequency bands. So here's the frequencies of the wavelengths, and these are the absorptions. So you can see this red here is CO2 absorption. It has several of them. So you can see it does a whole bunch right here. It does a little bit here, a little bit here, and you can't hardly see it, but it does some right in here. This here is water vapor and different things that do that. And here are the curves. So this shows you and we're going to talk about this in a second. So what happens is it's not linear. So, you would think, well, if I have 100 parts per million of CO2 and I go to 200 parts per million, the global warming is double, and that's not the case. It's much more complicated than that, is what I'm trying to say. So here's the one that explains it best for me. Max Planck, a doctor years ago, before 1947, I was 1 year old then. So basically, he predicted this Planck. So what it is, this is what is if there was no heat-absorbing gases, no water vapor, no gases of any kind, this blue line would be what is bounced back into the atmosphere from Earth. This is the radiation effect of Earth back into space. Well, the black line is basically CO2 at 400 parts per million. So at 400 parts per million, this also includes water vapor, comes around, and then it goes down here, So all the area under the curve has been absorbed by the CO2. Now, if you have 0 parts per million, then it's the green one, which is actually all black, and it goes right here. It doesn't have this heat absorption of CO2. That's missing. And down here. But at 800 parts per million, I just want to tell you the difference. You see this black line? That's 400 parts per million. The red line, that's 800 parts per million. It's almost exactly the same. It's slightly larger. It's about 2% or 3% larger, but it's definitely not double, even though we double the CO2. So this is something the climate catastrophe people don't want to hear. They don't want to hear anything about it. As far like Al Gore says, this is an inconvenient truth. And the way that Professor William Happer, Dr. William Happer, pointed out, which I really liked his presentation, he simplified it to make so that even I could understand it. He said CO2 is like painting a barn red. Say if you want your barn, you want to paint it red. So he says a barn painted red is like an atmosphere with 400 parts per million. You paint it red, it looks good. And you say, you know what, I think I'm going to paint it again to make it even more red. So you paint it again, and that now represents an atmosphere of 800. It's got twice as much paint on it, but it doesn't look any redder because it doesn't. And that's the same with CO2. The difference between 400 and 800, we will not see a difference except plant life on this planet will really like it. It'll take off, and we'll be a much greener world than we are today. So how are greenhouse gases removed? Water vapor is removed by condensation and precipitation. CO2 is naturally removed by photosynthesis of plants and dissolving in the ocean in form of carbonic acid and bicarbonate and carbonate ions. CO2 can be artificially removed by capturing through bioenergy or the CO2 air capture and storing in geoglyphic formations such as saline formations, oil and natural gas reservoirs, unminable coal seams, organic rich shales, and basalt formations. CO2 can also be stored in soils with biochar and in the future stored as pure carbon. So I think carbon storage is somewhat risky, because if you put it somewhere underground and thinking it's going to stay there and somehow it gets a leak and a crack, it's going to come back. So I'm not sure. I think it needs to be sequestered. The carbon needs to be tied up in some kind of mineral or chemical deal that it's tied up and can't be released without spending a bunch of energy. Other greenhouse gases are removed by chemical changes or being deoxidized. So more plants means less CO2. So all plant growth better with CO2, more CO2 in the air. So this is one with 700 parts per million, 300 parts per million, 270 parts per million, and you can see the growth is much better. The greening of our Earth, even today, we've seen much more greening in our Earth than we had back in 1965. And it's mostly in the arid regions. And the reason for that is a CO2 is food for a plant. So as it gets healthier with more food, it all of a sudden needs less water, which is why arid lands are seeing a bigger uptake than wetlands. Two main reasons why CO2 helps plants need less water if there is more CO2. There is less harmful photosynthesis and more CO2 today. C3 plants lose about 25% of their potential photosynthesis potential due to photorespiration. So photorespiration, I got a slide here, explain it. Here it is, yeah. Photosynthetic pathways. So as a plant brings in CO2 to eat, it has the process to happen, lets oxygen go out, and it also has H2O, water, come out from that plant. So as we get, this is a different kind of plant, it shows the same pathway. So as these little holes, I don't know what they're called now, but anyway, these pathways, they're actually on the bottom of the leaf. As there's more and more CO2, the plant doesn't need as many of them to eat because it gets fewer of them, so they has fewer of them. With fewer of them, the plant loses less water. So that's what makes it valuable to the plant. Not only does it get more food and CO2, but it also needs less water because it loses less water because it has less of these little pathways. Okay, now I know you can't read this, but this is CO2 emissions by the 50 largest producing countries. Now, this was a chore to try to figure out. I went to about 5 major sources of CO2 on the planet, and they all disagree. So this is as accurate as we're going to get, but it's not totally accurate. I may be off by 10% either way, because there's so many changes. Not only does the world keep changing, as in country borders and definitions and names of the countries keep changing, but also the way they're counted. Now, this is very complex. I don't blame it for not being accurate. It's impossible to count how much CO2 is coming from where, but they get a kind of an idea. I mean, they spend a lot of time on this, so I think, and these are the areas. There's 2 things I looked at here. One is population. That's also really hard to determine accurately, believe it or not. And they're all over the map, so that you may see some variances there, but I'm just trying to prove some general points here, not trying to be super accurate. CO2 emissions, these are the sources I have for all these. And per capita growth, I'm just going to say wild-ass guess because no one really knows, and I've kind of I've just interpolated out the data to try to get to those numbers. So here's the CO2 emissions project comparison. So here's the population growth. It says by 2025, almost 8 billion people on the planet. And here's how that breaks down into different groups according to what I've projected. This is the CO2 megatons. This is in metric tons. It shows you who's the big one. You know, China is always the big one. And this is the U.S. comes right next to China. And all the rest of them come out in the percentage that they have as of 2025, predicted for 2025, and the different sizes. So we can see these are the countries with CO2. This is a population by 2050, 9.3 billion, and that's kind of the guess. What is interesting about this prediction is that China will not be the most populous country. India will overtake them by 2050 because China population is going down fairly quickly. It was very surprising to see those numbers come down that quickly. So the things they've done in the past are actually catching up with them. And then this is the CO2 megatons. So in 2025, we're 73 million tons, metric tons, and it will be 42 billion, I'm sorry, not million, 37.6 billion metric tons, 42.2 billion metric tons by 2050. And those are the predictions that I think are probably I don't think you're going to change these much. I mean, we can do some improvement and do less CO2, but you need to understand we can't do it alone. This is a world issue, and the world has to do it. We can't do it by ourselves. How much impact will a 25% reduction in U.S. CO2 make? A 25% reduction will make a 3% difference worldwide. It won't be much. It'll be some, and we probably should do what we can, but we can't, if we just wiped the U.S. off the earth, no people, no industry, nothing, it would only change the world 3% and maybe less because of the growth potential we're entering into. This shows how we cannot do it alone. The world must engage to make an effort for any meaningful reduction. So here's per capita reduction. Here's how many people, of course, 2050. You can see that the per capitas are fairly high. And what drives the per capita is oil countries. Countries who produce oil because they have a lot of waste CO2 coming off gas tanks. And that's one thing we could probably cut CO2 across the planet is come up with ways of not to burn flare gas some other way to capture the CO2 off oil well drilling and production. And we could probably make a significant change in CO2 by just doing that one thing. The big unknowns, prosperity increase in the third world, because the whole third world is growing and is trying to figure out how to get prosperous like us. To do that, they have to have energy. To make energy, they have to burn CO2. So this prediction in 2050 is predicted on no huge increase in this third world. Growth of electric vehicles. Now, that's not predicted in here. We're growing electric vehicles, but my point is we shouldn't be doing it by mandate. We should let it do it naturally. Electric vehicles are good things, like them, but by mandating it, then we're going to force electrification. And even smart people don't realize that an electric car doesn't make CO2 directly. It just makes it somewhere else. Someone has to build the power, and that power may be being made by coal power plants, which are terrible for CO2. So we have to make sure that's done right. Growth of AI. We didn't see this coming. And in phase 3 of this report, phase 2 and 3 of this report, part 2 and 3, we talk about the growth of AI, which is scary. I mean, I don't think we can meet the growth of it. I think it's beyond our capability in the United States to meet it for the next 5 years. It's predicting they may need from 75 to 128 gigawatts of production. That's building 75 to 100 power plants a year. It ain't going to happen. I mean, over the next 5 years. These are big power plants, not little ones. Growth of blockchain or Bitcoin. These also require tons of energy. That's why I'm not in favor of blockchain or Bitcoin, because it's just squandering our energy reserves for profit. Makes no sense to me. Growth of new technologies that use electricity. There's a lot of things we never heard of is going to come online. It's going to all need more electrical power, and that's going to drive this scenario. Innovation of low CO2 power generation, that would be good. If we could figure that out. Innovation of CO2 capture technologies. It's kind of ugly right now. If we could do that, we could help lower the CO2. Actual implementation of low carbon strategies. We're still arguing about it. That's one of the things that bothers me more than anything about the catastrophe theory. It's prevented from people actually doing anything. They argue back and forth and do nothing. So that's kind of a bad thing. Fusion power becomes a reality. That will help if that ever happens. It will happen, but it'll be a long time. What happens if CO2 begins to climb? Here's the prediction. CO2 levels. Temperature will continue to rise. Yeah, it'll continue to rise. Probably about 1°C by 2100. So we're going to be a couple of degrees hotter on the ground. So it's going to be warmer. So in the northern climate, it's going to be much more temperate, much more comfortable. So it means all you people that have migrated down to the southern states may have to migrate back because it's too hot for you. trees and plants will thrive due to more CO2. This is the recordings I had, 2,371, 2020, 413. I think it'll take this. I think by 2050 will be at 543, and by 100 will probably be right up there around 800. So that's my guess, but it is a guess. Remember the limits. The recommended limit of CO2 is 1,000 to 1,200 parts per million. I think if we let our ppm of CO2 go beyond this, we're just inviting a tough time. So we need to be aware of that. So what does this mean? It just means as countries elevate, then the world needs to invent new things. I'm all in favor of technology, and we need to share that technology with the rest of the world to help since this is a worldwide deal, we can't do it by ourselves. We need to share those inventions with the rest of the world so that they can gain energy independence, can gain energy safety, and can lead a better life. So what are the final facts? Is our climate changing? Always. It's always been changing. It will always change. We can't stop it from changing. Is atmospheric CO2 increasing? Yes. Does human activities directly increase CO2? Yes. Is CO2 at the highest level ever? No. Was 24 the hottest year ever? No. And this kind of bugs me, being a HVAC guy, I deal with temperature all the time, is that the news media says the hottest year ever. But that's misleading because what everyone hears, it's the hottest temperatures. And it's not. It's not what it is. It's the hottest, lowest temperatures. So those low temperature records are not being broken anymore because the temperature's coming up, which means we're more dependent. But the heat records are not being broke. The heat records we're breaking is for the highest temperature for the longest period of time. So in my state, Arizona, our high temperature of record is 122. This year, we probably got to 115 a couple of times. Nowhere near as hot as it has been in the past, but it was hotter for a lot longer period. I mean, I think we had 110 degrees over 110 degrees, 110 days over 110 degrees. So it was hotter for a lot longer period of time. They're records, yes, but the news media is misleading on what they're saying. Is atmospheric temperature rising? Yes. Does the level of CO2 in the atmosphere raise the world's temperature? Slightly. Like we said, from where we're at, going forward, CO2 will not make a near as big as impact as it has in the past. Is world temperature collapsing ecosystems on Earth? No. They predicted all kinds of disasters for this to happen, that to happen, and now they've all recovered. They said, well, I don't know what happened. We saw that they were, they said the coral reefs were all dying, but most of those are all back to life. Well, what happened? Well, they adapted. It's funny about nature. Nature has a habit of adapting. Us humans, not so much. Will increase CO2 and increase temperature in the world by 2050? Absolutely not. War may end the world by 2050, but not world CO2. So part one today, we covered about all the CO2. Part 2 covers how to set priorities for the best power production in the U.S., a data comparison of most current types of power plants, their CO2 production, cost, uptime, and lifetimes, can give you an informed opinion on what's the best power. Part 3 covers what should be concentrating on to improve our carbon footprint while improving our world and the lives of its people. So that's it. I hope this was interesting. I find it interesting. This is a hard subject to actually put together, but I hope it was helpful. So thanks for watching. Please share with your friends. Be able to do whatever you want with the video. And please, I want to see you on part 2 in just the next session. Thanks a lot. Have a good day. See ya.